So when you do operations, differentiation operation or integration operation on the curve, their degree changes. So what is the change in the degree of the curves? For example, if you do integration, the degree of curve increases. When you do differentiation, the degree of the curve, it decreases. Remember this forever. When you do differentiation, you differentiate the curve, its degree decreases. You integrate the curve, its degree increases. Once you remember this, try to put it in the form of our XT, VT and AT curves. I had written some takeaways from our previous discussion of differentiation and integration. We have our VT curve, we have our AT curve, and we have our XT curve, right? So XT, VT, AT. What do you want to get? If you want to get XT from VT, what should you do? You should do differentiation, right? If you want to get AT from VT, that means you have VT but you want to get AT, or you have XT but you want to get VT. In all these kinds of things, we have to do differentiation. This we have already learned in our takeaways. When you differentiate XT curve, that means dx by dt, you get VT. When you differentiate VT curve, that means dv by dt, we get AT curve. Okay. Now the reverse is integration. Integration. Okay, so when you integrate AT curve, you get VT curve. When you integrate VT curve, you get XT. What is the parallel word that we will be using in physics for differentiation? We will be calling it slope. We will be calling this slope. So you find a slope of XT curve, you get VT curve. You find a slope of VT curve, you get AT curve. What is the parallel word that we'll be using for integration in physics? We'll be calling it finding area. You find the area of AT curve, you get VT curve. You find the area of VT curve, you get XT curve. Now, next question. What happens to the degree of the curve when you differentiate? The degree decreases. So here, degree will decrease. What happens when you do differentiation? Degree decreases. So if the degree is 2 here, it will become 1 and it will become 0 here. Okay, if it is 3 here, it will become 2 and it will become 1 here. But all the problems that you will be encountering, the maximum degree of XT curve will be 2. Because I have taught you curves of degree 0, 1 and 2. So at least at this level, you will be encountering only the problems that have degree 2 for XT curve. So 2, 1, 0 is what you will have, or you will have 1, 0 and no AT curve. That means you have XT curve, you have VT curve, but there is no acceleration, so no question of having a VT curve. Okay. Now, for integration, what happens to the degree? Degree increases when you find area or integration. Degree increases when you find area or integration. So AT curve to VT curve. If the degree is 0, it will become 1. If the degree is 1, it will become 2. So using the technique of finding the area, you don't know how to do differentiation, right? Because there are some formulae, standard formulae for differentiating things, differentiating functions, operating the derivative operator on functions. There are some standard formulae which you don't know yet. But do you know how to find slope? Yes, because I have already taught you that the slope is delta y by delta x. That means delta of y-axis on divided by delta of x-axis. You can find slope. You can find slope. How do you find area? You know how to find area. If it's a rectangle, it is length into width. If it's triangle, it is half into base into height. So you can very well find area. And I have given you this degree ka talk just to get an extra idea about how will the nature of curve look like. What do I exactly mean by that? I have given you the degree ka talk just to know how will the actual nature of curve be. Now, what is the meaning of all that? What is the nature of curve? When I say it's an inclined line, how does it look like? When I say it's a curve, how does it look like? When the degree actually decreases, what happens to a parabolic curve? That means a second degree curve. What happens to inclined line? How does it change from an inclined line to a 0 degree line. We will look into all that. We will take up one problem and we will use these techniques to solve that problem. The problem will be a basic one which we have already solved it by using three kinematic equations. You remember the problem, right? Your car started accelerating, it reached up to some maximum velocity, then it continued with that velocity, and then the driver applied brakes, the speed got reduced and the car stopped at the end. We will solve that problem using the techniques of this differentiation and integration. We will find all the values, we will use only the graphs, and we will find the slope of the curves in the graphs, we will find the areas, but we won't use our three equations of kinematics, and we should get the same answers that we got by using the equations. So we will try to use the basics of differentiation and integration that we have learned for solving a problem in kinematics using the graphical method, of course. Try to recall the problem that we have seen. The car starts from rest, it accelerates, that is its velocity goes on uniformly increasing for 10 seconds, and in that period it covers a distance of 50 meters. Thereafter it continues with whatever velocity it has achieved for 10 more seconds, and then thereafter the driver applies the brakes, stops the car in 2 seconds. Okay, so whatever data is given in the numerical, you remember it, we have solved this problem by using three kinematic equations. So whatever is the data given in the problem, I have written in black color. Whereas whatever the data we could find out using the kinematic equations, I have written in the red color. So what we have to do for solving this problem using graphical method is use the only data that is written in the black color and see if we get the data that we have put in the red color, because red color is the answers, black color is the given things. So we will only use the black color data. Red color data I have just put it there for your reference. Now let us try to apply the basics of derivative integration. So what we have learnt is the area of VT curve will give me XT, the area of AT curve will give me VT. The slope of XT curve will give me VT, the slope of VT curve will give me AT. These are the only four takeaways that we had from the basics of derivative and integration. We will try to apply them. So let us see what is the first given data. The velocity, initial velocity at point A is 0 meters per second. Since it is the data about the velocity, let us plot it in the velocity time curve, that is the second curve. So I will mark velocity as 0 meters per second at beginning instant, at initial instant. So 0 seconds, velocity is 0 meter per second at 0th second. So it will come at 0 on time axis and 0 on velocity axis. That is my point A. Now what is the next data? Remember, A and VB are not given, they are in red color, but the black data is the given data. So it moves for 50 meters and for a time interval of 10 seconds. So let us mark a time interval of 10 seconds. Let us say it is here. This is my 10-second time interval. In that, the car moves 50 meter distance. Now, where do you get this 50 meter distance or position related data is in XT curve, right? It is not in VT curve. So this data 50 meter should not be plotted here. What we should plot here is velocity. So what is the velocity at B that we could have plotted here, because this is our point A. Whatever is the velocity at point B, that is at 10 seconds, we should plot it here. But unfortunately, that data is not given. So let us try to find it with our basics. Let us say this is that velocity. I am not allotting it any value. I am just marking it on the graph at 10 seconds. We don't know how much is the value, that we have to find out. And let us join. So this is my point B. Let us join A and B with an inclined line. You know the degree of this line, we have already seen. It is a line, an inclined line, also of degree 1. Okay. Now I have joined them, but I don't know how much is value of that on vertical axis. Now what do our basics say? We know that area under VT curve is equal to change in the position, right? Just refer a few minutes before, we have seen these principles. So area under VT curve is change in the position. What is the area under this VT curve? Where is your VT curve? The second curve is VT curve. What is the area under this curve? It looks like a triangle, right? This shaded portion, shaded in red color. This is your area under VT curve. It looks like a triangle, so area is simple. It is half into base, which is 10 seconds, into height, which is VB. We don't know that. Equal to change in the position that happens from A to B. What is the change in the position that happens from A to B? It is 50 meter, and that is known data because it is in black color. So just put it there. Therefore, you get your VB equal to 10 meters per second. Just do a quick calculation. You will find that it is equal to 10 meters per second. Try to verify with what we had got with our kinematic equations. VB is equal to VC is equal to 10 meters per second. That means VB is equal to 10 meter per second. VC will also be equal to that because it is given in the problem that it continues with constant velocity from B to C. And that is why VB and VC will both be 10 meters per second. So let me put here that it is 10 meters per second. And let me extend the line with constant velocity of 10 meters per second for how many further seconds? 10 seconds, and it's a given data. So this will be 20 because it is 10 more seconds, right? This is 10 more seconds. This is 10 seconds. This is another 10 seconds. So that becomes 20 on the time axis, right? Now, let us put some data on our XT curve simultaneously. We know that 50 meter, because now we'll be moving from AB section to BC section. So before that, we should not miss out anything that is there given in the AB section. So what is the given data in AB section about XT curve? It is 50 meter change in the position that is happening. So assuming that the car starts from 0 meter position at 0th second, it will have to move to 50 meter position. So let us say that 50 meter location is somewhere here. 50 meter. Okay. And after how many seconds does that happen? After 10 seconds. So just extend this here. This is your 10-second mark. And this is your 50 meter mark. So just join them. This is your point B on position time. This is your point A on position. Now A to B, how will you join that? Refer our previous discussion. If you move from VT to XT curve, the degree of the curve increases. If you move from VT to XT curve, the degree of the curve increases. What is the degree of this curve? It is 1. So what should be the degree of this curve? It should be 2. And that is why it will look like a parabola. Okay, this curve is called as parabola. I had shown you 3 curves, like, right? An inclined line, a horizontal line, and a parabola. So this is that parabola, which is a curve of 2 degrees. Now, going to BC section, it moves there for 10 seconds with the same speed of 10 meters per second, right? That we have already plotted. Now, again, area under the VT curve should give me change in the position. So, area under VT curve should give me change in the position. This is for section AB. This is for section BC. Okay. So what is area under VT curve? Now it looks like a rectangle, right? What is the area of a rectangle? It is length into width. So how much is it? 10, 20. So what is the difference? This is only 10 seconds. Into what is the height? It is 10 meters per second. So 10 into 10, which is 100, should be equal to change in the position. Remember, I have already told you in physics, if you hear a word change, change is always final minus initial. So that means for section BC, it should be x at C minus x at B. Final position x at C minus x at B. Now what is x at B? What is position at B? It is 50 meter. And substitute it here. What is this? 10 into 10, 100 is equal to xc minus 50 meter, right? And that is why we get xc is equal to 150 meter. From where? From beginning. So from beginning, that is from A, it is 150 meter. This distance is 50 meters. So how much should this be? 150 minus 50. This distance should be 100 meter, and that is what you can see in the red color. That means using kinematic equations, we had got the same answer. So here is our 150 meter position, and it is at what time? At another 10 seconds, so 20-second mark, right? So this is that location. Now how to join B with C? How do you join them? Look at the nature of VT curve in BC section. Look at the nature of VT curve in BC section. How is it? It is a 0 degree curve. So this should be curve of degree 1. That means an inclined line, right? That reaches up to 150 meter from the beginning. That means this distance is 100 meter, which we have also got using kinematic equation. Moving to the section, third section, that is section CD. Okay. So section CD, what is the given data? Look at the black color data. What is given data? Final velocity is 0 meters per second. What is the time? Black colored. So given data 2 seconds time. So 2 second time will be somewhere here, that is 22 seconds from the beginning. So 20 and 22, the difference is 2 seconds. And final velocity reduces to 0, so it has to linearly drop down to 0. That's our VT curve for this much time interval. Now what is the area under the VT curve? Same principle once again. Area under section CD. So area under VT curve should give you change in the position for your CD section. Now this is D, right? So CD section, for that we will get XD minus XC, final position minus initial position. Therefore area under VT curve, it's again a triangle. So half into base is 2 into height is 10 equal to XD minus XC. What is XC? Position of C is 150, and therefore we will get XD is equal to 160 meter, right? From where is it? It is from A. So from A 160 meter, that will be just here 160 meter, because already we have reached to 150 meter position. So 160 meter is just 10 meter ahead of your point C. Look at the answer that we had got using equations of kinematic. CD distance is 10 meters. So this is 1, this is 50, this is 100. So 150 plus 10 meter, that reaches to 160. Now let us take this 160 mark and let us take this 22 second mark. We got our point D on XT curve. How to join them? Again, think. This is an inclined line. Inclined line is always of 1 degree. But do you see a difference between AB inclined line and CD inclined line? What is that difference? AB inclined line is increasing in nature, whereas CD inclined line is decreasing in nature. So remember, when you have an increasing nature of VT curve, linearly increasing nature of VT curve, XT curve looks like this. Whereas when you have a decreasing nature of VT curve, your XT curve looks like this. Do you notice the difference between the nature of the two curves? One is bulged inside, the other one is bulged outside. So that is the only difference that we have to make. Otherwise this and this both are curves of degree 2, whereas the central one is the curve of degree 1, which is an inclined. Now we have completed our XT and VT curve. How many data points have we got using graphical method and that tally with your kinematic equation method? We have got our velocity, it tallies with 10 meters per second. We have got our distance of 100 meter, we have got our distance of 10 meter. Now the only data that is remained is these two, which are acceleration data, because we have not yet reached acceleration time curve. Now acceleration time curve is very easy. You only got a simple principle that slope of VT curve should give you 80. So find the slope of VT curve. Slope, how is it defined? Change in y-axis distance divided by change in x-axis distance. So consider section AB, that is 10 second, this is 20 second, and this is 22 second. So what is change in y by change in x? Because we know that slope is defined as change in y by change in x. Slope for Vt curve. Slope for Vt curve, that will give me 80. So what is slope of this Vt curve, or change in y by change in x of Vt curve? How much is y change? It is 10 meters per second, right? What is this x change? It is 10 seconds. So acceleration, and is equal to acceleration. So acceleration is equal to change in y, which is 10 meters per second, divided by change in x, which is 10 seconds. So that gives me 1 meter per second square of acceleration. For which section are we talking about? AB section. See if it tallies your kinematic equation. Kinematic equation ka data, it tallies, right? 1 meter per second square in section AB. So, and it's constant everywhere because slope is same everywhere. On this line, wherever you take slope, the slope is basically the inclination of the line, the angle of the line, it is same everywhere. And that is why mark your acceleration of plus 1 meter per second square in here. Now what is the slope of line BC? Slope is change in y by change in x. Line BC is horizontal. So when it is moving horizontally, there is no change in y. There is only change in x, that is time axis, but on velocity axis there is no change, it's horizontal. So no change is 0, so in the numerator will get 0, and that is why there is no acceleration in this section, which is obvious because the velocity does not change in that section, and no change in velocity should implement that there is 0 acceleration. Thereafter, moving to the last section, CD section, where change in y by change in x. So what is change in y? Now you would say change in y is 10, but I would say no, because change is always final minus initial. So what is the value at, or value of velocity at final point? It is 0. So let me just write it down so that it will be very clear. Slope, that is acceleration, is equal to change in y. Change in y is y final minus y initial. We are talking about CD section. So what is your velocity at D? It is 0, minus velocity at C is 10, divided by change in x is of 2 seconds. This is meters per second. So you will get it as minus 5 meter per second square. Acceleration in CD section. So minus 5 would go somewhere over here for next, oh sorry. So we should draw it between 20 and 22. So it should go somewhere here, right? This is your minus 5 meters per second square acceleration, basically deceleration, because it is negative acceleration. Look at what we had got using our kinematics. The same answer. Now this is not surprising because your kinematic equations, they themselves govern the nature of these lines. So whatever 1 degree curve, 0 degree curve, second degree curve, whatever curves I had told you, those kinematic equations, they express these curves. So kinematic equations are expressing the graphical method. That is why by any of these two methods you must get the same answer. Okay, so this was just to illustrate the power of graphical method, because it makes the visualization of the motion easier than it happens with kinematic equation. Because kinematic equations are like you just plug in the values and you get out the answers, but you can't visualize the motion. Here you can visualize how the particle is moving with time, how its position is changing, how its velocity is changing, and how its acceleration is changing. And that is why a graphical method is an important tool to analyze 1D motion. Okay, thank you.